In the top half of page 513 in the notes, we've got a function and we've got its graph made, and they're asking us to calculate a few definite integrals. And so this is, again, going to be kind of an easy application of our geometry knowledge, but let's take a look at how that works because it is a problem type that you will be exposed to. All right, so we don't have the expression of this function, but that's okay because the graph itself is kind of easy to understand. All right, so we can just kind of decompose this into parts. So that's obviously intended to be a semicircle, and this is a straight line. And so as we're kind of picking these areas apart, we can see that we can find the areas of each of these things just using our geometry knowledge. All right, so if they want to know the value of the integral from 0 to 3 of f of x dx, that's the area from here to here. So let's add up all of those regions. So this rectangle has a length of 2 and a height of 1, base of 2 and a height of 1, I suppose. So we can say that this has an area of 2. This triangle has a base of 1 and a height of 1. So that means it's an area of 1/2. Or we could just think that it's half of that square, which has an area of 1. So this has an area of 1/2. And the area of a circle, let's say the area of a whole circle, is equal to pi r squared, where r is the radius. So I can tell here that the radius is 2 units. So that's 2 squared times pi, which is 4 pi. But we don't need to know the area of the whole square. We only need to know the area of a quarter of the square. So that's 1/4. I should make it a little bit more clear that that's a 1/4 of 4 pi. So that's just equal to pi. All right, so if we want to know the definite integral from 0 to 3 of f of x dx, we just need to add up all of the areas here. These are all above the x-axis, so we're going to be adding these all together. So this is 2, that gives us 2.5, and that gives us a total of, let's call it 2.5 plus pi for our area there. The next problem asks us about the integral from 0 to 4. So now we're just thinking about everything we just did, except we want to add this extra triangular region here. So what number should I put down here to keep track of what this definite integral from 3 to 4 would be? Well, the area of this triangle is 1/2, just like the area of this triangle is 1/2, but this is below the x-axis. So let's write negative 1/2, just to make it clear that this is going to be a negative definite integral because it's below the x-axis. So to think about the value of this, we can take the definite integral from 0 to 3 and just add in this extra negative 1/2 from 3 to 4. Or we can add these 4 parts together. We can think of it either way. But either way, we're taking out a half. So we're going to get 2 plus pi for our answer. And the last question here is they want to know the value of the definite integral from -3 to 3. All right, so we could add up all of these regions and then add all of these 6 things together. Or we could use one of the properties of definite integrals that we looked at from earlier in this section. What do I notice looking at this function that's going to make this calculation easy for me? Well, this is very clearly, at least over the part of the graph that we can see, this is an even function. It can be reflected across the y-axis. So to find the integral from -3 to +3, I just have to take this integral I've already calculated from 0 to 3 and double it, because this area over here is going to be the same as this area over here. So I'm just going to take 2 times 2.5 plus pi, which is equal to 5 plus 2 pi. All right. So the next two parts at the bottom of this page are just a little bit trickier. We'll tackle them in a separate video because we're going to need to pull out a little bit of extra calculus knowledge from back material in order to answer them.